Hi there and welcome to Penguin Learning. In this National 4 Maths lesson, we will be looking at sequences. After watching this lesson, you will know what is a sequence, and you will be familiar and able to give example of several different sequences. You will also know what is a term within a sequence and how this relates to finding the equation of a sequence, and you will know how to do this after this lesson. So, let's get started.
Ooh la la!
So, sequences. Let's begin this lesson by asking the question, what is a sequence? And it's basically just a set or list of numbers that are connected in some way, and the numbers within this sequence are known as terms. And what we're going to do just now is just go over some of the more common sequences that we might come across. So to begin, let's have a look at some even numbers. Now, an even number is just simply a number that can be perfectly divided by 2. In other words, when it's divided by 2, there is no remainder or numbers after the decimal point. And if we list out some of the even numbers here, we can see that they form a sequence because they're connected. The terms are connected in the fact that each one is perfectly divided by 2. And also, as we go along each term in this even number sequence, we can see that we are adding 2 on each time in the numbers. So we have 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, 10 plus 2 is 12, and so on for all the even numbers that there are. And of course, on the flip side, we also have odd numbers. So even numbers were numbers that can be perfectly divided by 2, but odd numbers are numbers which cannot be perfectly divided by 2. And this also forms a sequence with each term being an odd number. And just like the even number pattern, each number we're adding 2, so we begin with 1 for the odd number because 1 is the first odd number, and plus 2 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 11, and so on. And for both the odd and even number sequences, we are adding 2 on each time, and that's because if we start counting from 1, we have an odd number, then an even number for 2, odd, even, and so on. So both the even numbers and the odd numbers are examples of sequences. Now here is 2 other examples of sequences. The first one we have multiples of 4, and the second one we have multiples of 7, or in other words, we have the 4 times table and the 7 times table. And for the multiples of 4, the way that these numbers are connected is that we're adding 4 on each time. So if we have 4 plus 4, that gives us 8, 8 plus 4, that gives us 12, 12 plus 4 gives us 16, and then so on. Or we can also think of it as 4 times 1 is equal to 4, which is the first number. 4 times 2 is equal to 8, which is the second number. 4 times 3 is equal to 12, which is the third number, and so on. So we can see that these numbers are clearly connected through the 4 times table. And the same can be said for the multiples of 7. So we can see that for each number we're adding on 7. So 7 plus 7 is 14, 14 plus 7 is 21, 21 plus 7 is 28, and so on. Or again, we can think of it as the first number is equal to 7 times 1, which is 7. The second number is equal to 7 times 2, which is 14. The third number is equal to 7 times 3, which is equal to 21, and so on. So the pattern continues, and all of these terms are connected through the 7 times table, so it also can be described as a sequence. So let's have a look at these set of numbers now. Let's assume that we already know this is a sequence and we know that these numbers are connected, but we have to find out how and why they are connected. And in fact, all of these numbers are known as square numbers. And square numbers are just the products or the multiplication of a number multiplied by itself. So that means that if we begin with 1, multiplying 1 by itself would be 1 times 1, and this can also be written as 1 squared. And because 1 times 1 is just equal to 1, then 1 is our first square number. Then if we go on to 2, if we multiply 2 by itself, it's 2 times 2, or we can say 2 squared, and that is equal to 4, which gives us our second square number. And this pattern continues on along this sequence, so we have 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64. So do you think what this next number can be? So the next number is going to be 9 times 9, which is also equal to 9 squared. And that means the next square number is equal to 81. Okay, so the final sequence that we're going to look at right now is the power of numbers, and in this example here we have the powers of 2. And when we're talking about the power of a number, we're just saying how many times we are multiplying it by itself. And the way that we write the power is we have 2, so because it's doing powers of 2, and then the power number is just written in the top right corner above the number. So I said the power number just indicates how many times to use the number in a multiplication. So because it's only 2 to the power of 1, that just means that we only have 1 2, and that's the case for any number. So if we have any number to the power of 1, then the number just stays the exact same. But now let's say we have 2 to the power of 2, which is the exact same thing as 2 squared. So 2 squared, or 2 to the power of 2, it's the exact same thing, it's just a different way of reading it. But we know that because the power number is 2, that we're multiplying 2 twice. So that would just mean that's 2 times 2, and we know that is equal to 4. So what about 2 to the power of 3? Well, this is also known as 2 cubed. So 2 cubed and 2 to the power of 3 is the same thing, and that means that we're going to multiply 2 by itself 3 times. So we have 2 times 2 times 2, and we know that, well, we know 2 squared is equal to 4. So that means this is the same as 4 times 2, which would just be equal to 8. Because 2 times 2 is 4, and 4 times 2 is equal to 8. And in this sequence, this pattern continues on. So we have 2 to the power of 3, 2 to the power of 4 is 16. So what now if we want to figure out 2 to the power of 5 in this sequence? So we have 2 to the power of 5. So that means that we are going to multiply 2 5 times. So we have 2 times 2, times 2, times 2, and one final 2. And from this sequence, we already knew the previous answer, so we said that's 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4 is equal to 16. And because that's the case, that would mean that we can rewrite this as just simply 16 times 2, and then that would mean that 2 to the power of 5 is equal to 32. Another way of thinking of the terms within this sequence, the power of 2 sequence, is that we're doubling the number each time we move on. So if we double 2, it becomes 4, 4 doubled is 8, 8 doubled is 16. We then said that 16 doubled is 32. So the number after 32 would be 2 to the power of 6, and to get that we could just double this number, and to do that we times it by 2. So that means the next one after 32 would be equal to 64. So we have to learn to recognise patterns and how these numbers are connected within a sequence in order to generate the next term. So going back to the even number sequence, we're going to have a closer look at each term. So to put it simply, because 2 is the first number to be in this sequence, then it's simply just denoted as the first term, and then 4 is just simply the second term. We have the third term, fourth, fifth, and the 6th. So this sequence here just now consists of 6 terms. And because we know the pattern for even numbers, we can just simply add 2 on each time. That means we can find out the 7th term, which is 14, the 8th term, which would be 16, and so on. But sometimes when we go to solve problems, we may want to know a term that's a lot further down the line. So let's say, for example, we wanted to know the 6th to 8th term within this sequence. This is a little bit harder to figure out than just simply counting, so we need another way of figuring out what terms can be in the future. And the way that we can find out any future term is by using an equation that can relate all of the numbers within the sequence. So to find an equation, I've just written this out a little bit differently. So basically what we have here is the number in the term. So this is the first term, the second, the third, the fourth, and so on. And what we want to do with an equation is allow us to find whatever number of term within the sequence it is. So maybe we want to find out the 10th term, the 25th, or let's say the 60th term. We want to find an equation that will allow us to do this with ease. And what we call any of these future terms is known as the nth term. and the nth term just symbolises any possible future number that we want to figure out. So step 1 to find an equation for this sequence is to find the difference between each term, and for this equation to work we have to make sure that the difference must be constant, which means that the difference must be the same for each number jump. And we can see that for an even number sequence we're adding 2 on each time. So we said that 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, and so on. So that means that we have a constant difference, and this difference is equal to 2. So just quickly, what I'm going to do is call all of the numbers in our even number sequence S. So we have the name of the sequence, we have the difference in the terms between the sequence, and our goal is to find a future term, or in other words the nth term. And these can all be related now by saying S is equal to the difference, which is 2, and then n. So S is equal to 2 times n, or in other words, for any S within this sequence, that is equal to 2 times whatever n number it is within the sequence. So this normally represents the first part of the equation. Sometimes we may have to adjust after it by adding or taking away a number, and the way that we decide if we need to do this or not is just by simply looking at all the n numbers and then now all of the s numbers and seeing if this equation is correct. So our equation as it stands is s is equal to 2n. So that means if n is 1, we put this in the equation, that would be 2 times 1, and that means s is equal to 2. So that's the exact same as we have here. When n is 1, s is 2. And this is also correct for when n is 2, s is 4, n is 3, s is 6, and so on. So this equation is correct for this sequence. And now what that means is, because we have an equation relating s and n, we can find out whatever term we want within the sequence. So let's say we want to figure out the 20th term within this sequence. Well then all we have to do is substitute in n is equal to 20. So we would have s is equal to 2 times 20, and that means that the 20th term within the sequence would be equal to 40. So here we've been given a sequence and we've been given a question in 2 parts. So for part A we've been asked to find the nth term within the sequence, and for part B we've been asked to find the 10th term in the sequence. So let's begin with part A. So when we are asked to find out the nth term in a sequence, that just basically means find an equation in the sequence so that we can find whatever term we want as the sequence goes on and on. So step number 1 to finding an equation, we have to find the difference between each of the numbers and make sure that this difference is constant. So we can see that the difference between 5 and 1 is plus 4, 5 and 9 is 4, and 9 and 13 is also 4. So that means for step 1 that is complete. And then now I'm just going to label each term by the order they appear. So this is the first term, the second, the third, and then the fourth term. So here we have the number of terms, and then here we have all of the terms within the sequence. So the number of each term within the sequence is classed as n, and each term actually within the sequence is s. So the first step, in order to relate both n and s, we can say that s is equal to the difference, which is 4 times n. And then the second and final step, all we have to do is check this is correct and adjust. So if it's correct, then this is the final equation, but if it's not, then we have to adjust this by either adding on or taking away something after the 4n. And again, how we check it is correct is we can sub in any value of n and see if it gives the correct corresponding s. So for simple reasons, I'm just going to select the first n and s. So n is 1 and s is also 1. And what we do, we put the value of n in our equation. So n is equal to 1, so that means we have 4 times 1, which is just equal to 4. And then what we have to do is compare our s values. So here the s value was 4, but really the s value that we wanted was 1. So that means that this answer is bigger by 3, because 4 minus 1 is 3. So that means we have to adjust the equation of s is equal to 4n so that we end up with an answer of 1 instead of 4. And the simple way of just doing that is to take away 3. So if we have 4n is equal to 4 minus the 3, that will give us a value of 1. Now let's just double check this for one other value of n and s in this equation. So let's say now when n is equal to 3, we know that the s value should be equal to 9, so let's put n is equal to 3 into our new equation. So we have s is equal to 4 times n, which is 4 times 3, and then take away 3, and 4 times 3 is just equal to 12, minus the 3, which gives us an answer of 9. So we now know that this equation of 4n minus 3 is correct for our sequence. So that now means that we've solved part A and said that for any nth term, s is equal to 4n minus 3. Now for part B, we've been asked to find out the 10th term in that sequence, and all that means is n is equal to 10. And if n is equal to 10, we can put that into our equation for the sequence, and we can say that s is equal to 4 times 10 minus 3, and 4 times 10 is equal to 40 minus 3, and then 40 minus 3 just gives us an answer of 37. So that means that the 10th term in that sequence is equal to 37. Okay, so let's summarise this lesson we had on sequences. We said that a sequence is just simply a set of numbers that are connected in some way. And some examples of popular sequences were even numbers, odd numbers, and we also looked at times tables as well. So we said that any times table or multiples of any number is also classed as a sequence. And we also had a look at square numbers and also numbers to the power of something. So we had a look at, in particular, numbers to the power of 2. And all of these are examples of sequences because the terms within the sequence are all connected. And we also learned how to find out the equation of a sequence, or in other words, how to find the nth term. So step 1 is to find the difference between each term. So in other words, the difference in the jump between the first and the second term, and the second and third term. And this difference between all of the terms must be the same, it must be constant. And if we can call this difference d, then we can say that the first part of the equation is s is equal to d times n. And then step 2, we check if this is correct and adjust accordingly. So if it's correct, then we leave it as it is, but if not, then we adjust it. And how do we check if it's correct again? Well, we can select the one value of s and n, and we sub in the value for n into the equation. And if the answer gives the same value as s, as this does here, then the equation is already correct. But if it's different, then we have to add or take away the difference between this value and this value here. So I hope this lesson on sequences has been helpful to you, and if that's been the case, make sure and give the video a thumbs up. But if you have any questions on the video, don't hesitate to drop it down below. And if you'd like to see more content like this, check out our website at penguin-learning.com and make sure that you're subscribed to our channel. Thanks again for watching, and I'll see you in the next video.